Great, great, cool. I'm David. Hello. Thank you so much for having me in Istanbul. Cool. I'm David. I'm a member of technical staff at Anthropic. I'm also the co-creator of MCP and currently what people would call the BDFL of MCP, which means I get to make the final decisions, and if there's anybody to blame, it's also me. Great. So keep all your complaints for later, and then we can go from there. Okay, where do we start with MCP? A quick overview of like where do we started, where it's going. A brief overview of like what MCP is, and then I look into like where are we going from here. 1 year after the release, which was actually yesterday. So yesterday, a year ago, we released MCP to the world. Not knowing honestly what we are doing at the time with it, how big it will become. At the time, it was Justin and my little project on the side that we were lucky enough that we have executive sponsorship at the company to really go out and like open source this in the way we wanted to do it. And I was saying to Justin at the time that I believe within a month nobody will talk about this. And yet here we are, a year later, we're still talking about MCP. So things have gone quite well. But why did we do MCP? Initially, at Anthropic, we did MCP out of a few reasons. We had a set of applications, desktop applications, IDEs, but also like early forms of agents. And all of these needed to connect to data sources. That can be, for example, the file system at the time, that can be data sources like Postgres databases and so on. And we were building these over and over and over again. Or worst case scenario, we often sometimes just copied things into Cloud Desktop, copied stuff out of Cloud Desktop. And I was thinking there needs to be a better way of connecting these type of things. And so in order to not have to implement the same thing over and over and over again for every of these applications, why not build one abstraction layer as a protocol and being able to speak with all of these integrations directly to all of these applications. And that is what people commonly refer to as an n times n problem. You have n clients, you have m amount of integrations, and you want to connect them. And the right way to do this is usually via a protocol. And so that's how MCP was born. And it was very much inspired at the time by similar solutions in this problem space. For example, the language server protocol, LSP. And so MCP, LSP, these things are very similar if you really look under the hood. And I want to just show you, this was actually the very first demo that Justin recorded at the time. So this looks quite janky in comparison to modern Cloud AI, but that was Cloud AI a year ago. Just looking into some Postgres database and being able to ask back at the time Claude 3.5 about like diagramming the relationships between the database schema. And here we're already making actually use of most of MCP at the time, more than what people do today. It uses both tools as well as resources. And so you were able to show that you can like diagram a database quite nicely in Cloud AI. And that was one of these original ideas that we tried to do, is bring integrations into applications like Cloud Desktop and Cloud AI. Now, of course, today, this is slightly different. Today, we're talking mostly about agents and not just as much about applications. And so in agents, you really have this like, you know, prompt input, some form of an agent, and then some form of a result. And still in agents, if we build more and more agents, we still have this problem of having these different connectors that we require. And this is amplified in the agentic world because agents really want to use a lot of tools in order to connect to different data sources. One of the most common type of agents you're using maybe is something like Claude Code, something like Gemini CLI, or something like that. But besides that, people write more and more workflow automation that, for example, require a form of agentic work to do something. A friend of mine, he has 2 kids that are growing up. He wants to sell a lot of old stuff. So he has automation that uses MCP servers to go take a bunch of pictures Like he takes a bunch of pictures, he uploads it to his automation, the automation takes it, identifies what the object is, gets a rough price point of the object, and then creates basically an online Facebook, Craigslist type of listing, so he can sell his stuff very simple in all of it, because he has like the opportunity to build these, to connect to like an agent, his data source, which in this case is like the German equivalent of Craigslist with MCP. So basically the whole point is like nowadays it's not just, you know, about these applications that don't scale in terms of integration, but also about agents that don't scale in integrations. And so having one common language here again helps really scale you the integrations up significantly, which will make agents significantly better. And then of course, if you're using agents today, there is a large ecosystem of pre-built MCP servers that you can now use on a day-to-day basis, right? The Turkish MCP, Airlines MCP server is one of these integrations. There's actually a lot of others. In fact, there's roughly 10,000 of these nowadays. And then if you really have more and more of these integrations work together, you're getting more powerful combined workflows where something like or Claudia can really make use of these integration, orchestrate across them. So in this example, we are creating a set of tasks from one integration to another, and it does all of this automatically. So this is an early, like, small iteration of an agentic flow where multiple data sources come together to really create these, like, really nice automation workflows that we're seeing more and more that are enabled through something like MCP. And so this is really the main reason why we have built MCPs, to like allow for this large set of integrations to be reusable across a wide variety of applications, agents, and agents, yeah. So, and the whole thing, again, started a year ago. I don't want to like bother you too much with these technicalities, but it's basically a year, and there's a lot of like really big stuff that has happened. We had one of the first big milestones about you know, December, January timeframe last year was the Cursor adoption. We had the VS Code adoption in March. And then really in May, June was the really big moment. There was a week where I think Satya, Nadell, Sam Altman, and what's the Google guy called? The Google CEO? Yeah, all three of them, Sundar, posted that they will adopt MCP. It was quite weird to wake up in the morning to Twitter and find yet another billionaire talking about your project. But there we are. And so that was really the takeoff point at which I think MCP gained what I would call escape velocity, where it is so big now and so widely used that it really drives the ecosystem nearly by itself. And then we had in August a lot of help from like people building MCP hosting solutions, and then we can talk about the registry later. But now we are roughly at 10,000 plus maybe 15,000 public servers. If you look at what people have built internally, in addition, we're probably looking, I would say, double the amount. So we're probably looking at 20,000 integration that people have built over a year. Which is quite cool, quite great. We have really big people like coming in, like the Snowflakes, the GitHubs, you know, HubSpot, GitLabs, Google Drive integrations, all of these type of things that work now on MCP. But when we talk about MCP, one of the questions I'm often getting is like, but why don't we just do an API? This sounds like an API to me. And there's a few things why we wouldn't do this and why this works so well, why MCP is different. The first one is that while like something like RESTs and in GraphQL are like somewhat standardized, they're not standardizing the full aspect of the integration, and particularly they don't standardize how to do authorization, they don't standardize how you do the specific description of tools and like other metadata that you would want to require in AIs. The second part, they're often not really documented, and you would have to, you know, in the case of open API specs, you would have to integrate like sometimes up to 4 really large documents that are somewhat not very well documented in order to use these type of tools. And MCP really tries to make this set much, much smaller by like forcing you to basically write fewer tools that are very well documented. And third, if you use a standard REST API, usually you have 20, 30, 50, 100 endpoints. If you look at something complicated like the GitHub API, it can be many hundreds. And that when you provide those to a modern LLM, it would confuse the model quite a lot. Because if you have an API endpoint that says search by name, search by ID, those are two separate endpoints in a REST API. If you give this to a model, the model would not know, is this an ID or is this a name? And it gets very easily confused. And so really making sure we have something that is specialized for LLMs, that is auto-discoverable, that is describing itself, was very important to make this really work well with models. Okay. Cool. Let me very quickly give you a very brief overview about like, now that we have hopefully established, oh, I do not want this. I do not want to call someone. Get out. Good. Have we successfully broken the presentation? Good. Turning it off and on again. So I'll briefly give you an overview of what MCP is, because the other part is that MCP is more than just tool calling, what most people associate with MCP. And so a lot of these questions come from like, why is this not an API? Why is this MCP? Come from this confusion that MCP is way more than pure tool calling. And so I just want to briefly go over these primitives now that we have established why would we want something like an MCP. So there's a few things that we expose. There's a client on here on the left side, which we have three things that clients can do. They can provide sampling, roots, and elicitation support. And then the server can provide three things: tools, resources, and prompts. And now that we are here, most people only talk about tools. So we're already like, MCP is way more than just tools. Some of it might not be very useful to you, but it exists. So what is there? Of course, tools exist as functions that you can provide for a model to take actions. So this can be like book a flight, search something, read a GitHub issue, these type of things. Read Slack. There are the common things that you see for the most part models use. They're very powerful. They feel a little bit like magic to people because the model automatically runs these type of things. So they're really the most backbone of MCP's interaction model by allowing you to provide functionality to a model. Second are resources. Resources are a bit different. Resources are supposed to be, for the most part, files, schemas, things that you can provide to the application that uses the model directly or to the model directly. And this can, traditionally it was mostly files. But this is actually not very widely used at the moment. But interestingly enough, it is the way and the mechanism that you require to deliver MCP applications, so the ChatGPT applications, they are coming via resources. So those are basically just like a big blob of text that you can provide to the model directly, and then the application using the model is able to either put this into the application, into the model context, or use it in a different way. Again, most clients today don't support this, but we will see a big use case of this when we talk about MCP applications, which is coming soon. Lastly, we had something called prompts. I don't want to talk much about it. It's barely supported anywhere. This was something we used very early. These are basically templates that you can use for like users to like enter directly into the context window, so you don't have to write them yourself. It's barely used, but it's quite neat, and at the time it was a useful idea. Less so today. There's two things that I do want to talk about because they are interesting. The first one is sampling. This is a thing that MCP supports, and some MCP client support where you can ask where the server itself, so you write an MCP server, for example, an MCP server that wants to read a Slack channel and summarize the Slack channel and then give it to you already summarized. Now, during the summarization, you probably want to use an LLM. So you have two options. You can either bring your own SDK and your own API key to use the model you want to use, or you can use the model that the client, so for example, Claude AI or VS Code is already configured and to use. And that's what sampling is doing. Sampling is nothing but to say, I, as an MCP server, want to go and request basically an LLM completion from the client and use that back by myself. This is super powerful, very, very useful, quite complicated to get your head around. But when clients support this, like VS Code, is quite an interesting idea for you to write an MCP server that makes use of LLMs without actually having to provide your own API key, without actually having to provide your own SDK integration. I don't want to talk about roots. I do want to talk about elicitations. And then lastly, and maybe besides tools, the second most important feature in MCP is something called elicitation. What an elicitation does, it's a mechanism when for example, you are, let's take Turkish Airlines again, because we just saw the MCP server. If you want to, for example, provide a mechanism to say, book a flight, and I want you to confirm that you as the user really want to book that flight for the given price. Now what I need to do is I need to make sure as the MCP author, a server author, that you as the user will be asked this question, do you confirm? Now the problem is when there's an LLM, the LLM calls the tool and says, book the flight, right? But now how do I make sure the user gets asked? Some applications will ask the user, should I call this tool? Some will not. So elicitations is a way to ask the user on the other side for more information. And so it forces the application like Claude AI to say, display to you, do you want to book this flight? And then you click OK. So it's a way for additional information asked from the user where a human needs to interact with it. And that's the important part. And that is very important if you run during a tool call, you want more information, you can ask for more. It can also be like, oh, what's your passport number, right? And you want the user to enter it rather than the LLM to provide it. You can use an elicitation for this because it asks the user instead of letting the model answer it for you. So those are the building blocks. And so MCP is already way more than just tool calling. Tool calling and elicitation is something very, very important to really build much richer interfaces for LLMs. And then tool calling, elicitations, and resources are really what later enables something like MCP apps, which I will talk about. Okay. I don't want to talk about like when do you want to, like, but maybe briefly, when do you want to build an MCP server, but I think we just saw a very good explanation of this. You want to build an MCP server in two case scenarios. Either you have a product that you really want to expose to people that feel will interact with it via a chat application, and your main value proposition is not the interface, but actually just the service itself. Like again, Turkish Airlines is a good example. You make money by selling the flight, not by providing the website, right? And so there are similar aspects like this. Shopify, for example, uses MCPs, and all their shops, you can use them via MCP servers. Why? Because in the end of the day, what I'm interested in is buying the thing, not providing the website necessarily. And so that's a great use case for writing an MCP server that for your company that is externally available to users. But where it's even more important, where we see most of the MCP adoption today is in big companies to give people access to internal data sources. And that's what we also saw in the previous presentation, where you have one internal chat interface and then all the data connectors like Jira, Confluence, and others that really allow people inside the company to be just way, way, way more effective and way more, and being able to access their data and from within the company. For example, in the morning, I use the Slack, like our internal Slack MCP server, to just tell me everything that happened in the channels I care about and summarize it for me. And that's my use case where I use a very internal server, and I actually use very little external servers because I mostly use it for work. So those are the two different scenarios where you really want to build an MCP server. And I do really believe that this internal use case is actually more important than the external one. Okay. What is this? I don't even know what this is. Cool. The next, so that's where we are today with MCP. So we have the base protocol that currently enables these 10,000, 20,000 integrations worldwide. Most of them are built around tools, some of them starting to use things like elicitations. We have a large set of clients being able to use it today. But what's coming up in the next, like what's the next thing we want to do? There's a few steps. The first one was actually yesterday. We released a new version of the specification that enabled a few interesting use cases. There's a lot of just like homework that we need to do, changes to authorization, things to improve user experience. But then there are 2 or 3 really big pieces that we want to make sure fall in place. And these 3 pieces are our 4 pieces in this case, actually. We want to enable more agentic flows. So we often have these questions around like, how do I have an MCP server expose an agent that is very long running, that might take like a day to complete, it takes 20 minutes to complete. And that's something we want to build. We want to look into how to provide richer interfaces, because currently all the interactions people have with MCP servers is pure text-based. And while text-based is great for agents and it's nice and for humans as well, it's actually not how we as humans naturally think. We are very visual. We look at things, we want to see something. When I want to reserve an airline flight, I want to see a seat selection, and I don't want to do this in text, right? Because I do not know what 39F means to anybody. I do not know where this is in a plane. So we want to enable richer interfaces. We want to think more about discovery, because at the moment, the way you discover an MCP server is very painful. You need to know the URL, you need to configure it, you need to enable it. If you think about it from a product perspective, how MCP servers work in most applications today, it's actually quite painful and not very seamless. And we want to provide the mechanisms to really make it significantly more seamless, so that these powerful AI models can automatically discover what you want to use. Because it is actually, if you really think about it, today in Cloud AI, you have to select the MCP server you want to use before you start the conversation. But at the same time, you're using these powerful models. They should figure this out for me, right? Why do I need to figure it out, right? So I think that's things we want to make better. And then last but not least, we have very big hyperscalers very much being all in on MCP, that be Google, Microsoft, and Amazon, and others. And these will have struggles with some of the current mechanisms of how the transport mechanism in MCP works, in scaling MCP servers significantly up. And so there's a lot of work that we need to do to make MCP easier to scale, and part of it is something we will call the stateless transport mechanisms. So those are the big focus points over the next few months and years to come. Because I want to live in a world where in a year from now, you can just seamlessly interact with something like Cloud AI, and it will just know the right MCP server. You don't even know that it's MCP. It should just work. You want to book a flight, you should be able to book a flight, and the model should be able to give you the cheapest flight. You want to, move a Jira ticket, around to, I don't know, Asana, it should just work. All you need to do is log in with your accounts and everything else should be taken care of. And that's the kind of world I want to live in, and that's what we're working towards. Okay, but let's go into a little bit of the specifics of what we currently do now. And actually is the newest thing that we added to MCP yesterday, which is called tasks. So one of the problems we're having is that currently, if you run a tool, you need to wait for the tool call to be done. So if you like talk to a model, you would wait. Now this is good for most cases, but there are some use cases, particularly around agentic workflows, deep research. So do some research operation for me. Look at all, like this research database, read all the papers, summarize them, come back to me with a result. This can take 20 minutes, 30 minutes, 40 minutes, right? Some operations might take days, right? How do you deal with this? This is what tasks is for. So tasks are a mechanism for an MCP client to start a long-running operations on the server and ask for updates frequently. Every 20 minutes you can say, is this task completed? Is this task completed? And your MCP server eventually will tell you when this long operation is done. This is today in the protocol. No client implements it, but we will see in the next 2-3 months support for this everywhere, which is why I cannot show you a good example of this, but we will see this everywhere where people will be able to write much richer interfaces in MCP because they can now do these very long operations and get very creative with how much you can do in the model on the server side. Again, agentic workflows are one part of this. Second part are like deep research. But there's a third part to that, is that tasks have a lot of overlap with existing protocols like A2A and ACP, because really if you think about agentic communication, all it does is you have an agent on one side, an agent on the other, and they need to communicate and say, I want to run something long, give me a result back, and vice versa. I want to run something long and give me a result back. So I think task is a mechanism for MCP to really enable agentic communication, which then begs the question why these other protocols, and that's a question I cannot answer, but others will be able to answer, because I believe they're not needed anymore. Simple as that. Because if you take, again, an MCP client and an MCP server, put it into the same application, you put an MCP client and an MCP server in the same application, you suddenly have symmetric communication that is basically like A2A. Very similar. And I think with task, you can do a lot of that today. And then, of course, second to that is the second model besides pure agent-to-agent communication. I believe the model that will be more prevalent is few generalized clients like ChatGPT, Claude AI, Gemini Pro that will use long-running agents and orchestrate across them in meaningful ways. And I think that will be the actual model. And I do believe that pure agent-to-agent communication will be less important for the next year at least. Okay, so that's the interesting stuff. So we will see these like very long-running tasks where people will write MCP servers that are way different than what we see today. And I'm really interested to see the developers like figure out what you can do with it. I have my ideas, but I have been surprised every time by the creativity that people do with these type of things that we put into the protocol. The next thing is very boring. So who here wants to talk about authorization MCP? Okay, great. One person. Then we can skip it for the most part. But basically, authorization is one of the most important parts to MCP. It is one of the most difficult parts to MCP because we are leaning on OAuth, and OAuth is very difficult. But as part of OAuth, one thing we are trying, and I think one thing people don't realize about MCP, MCP is really the first attempt ever to build a complete seamless plug-and-play mechanism between two components with authorization in between in the web. If you really think about it, everything that where you use OAuth today, you know the client already knows the server in advance because you register, you get a client ID, and that's the client ID you use. But that is not true for MCP. In MCP, I can take any client and connect it to any server. And so part of the problem here is OAuth is not perfect for this. And we used a mechanism called, and now we're getting very technical, we used a mechanism called dynamic client registration. At the time when we started using it, we asked the authors of OAuth, should we use it? And they said, it sucks, but yes, because there's no better alternative. It's terrible, but you must use it. So we did use it, and now we're improving it by actually changing OAuth itself, by adding a new mechanism to OAuth that's called client ID metadata, which makes a lot of this dynamic client registration stuff go away. And if you ever have to worry about OAuth and MCP, it makes a lot of things way easier. I don't go into the details, you can read all of it up, but that's it. So this is what this specification currently does. What we currently see now is enabling agent-to-agent communication, enabling long-running operations via tasks. We also do sweet little things that are nice for developers. We're adding icons, so you can have tools with icons, and the client can display icons. We have servers with icons. We can have more descriptions about servers. And then we have a lot of small improvements that you can read up to that I don't want to bother you with. But where does this lead us? So we will have long-running operation. We still want to go and build a better transport. We still need to go and figure out what's the next iteration for agent and for us as humans dealing with agents. And here is where MCP apps comes into play. And the previous presentation talked about this a little bit, but I want to go into a little bit more detail. So there was this thing called MCP UI, which was this idea that you can deliver, again, and I explained what was previously explained, but was this idea that you can basically deliver interfaces via MCP to a chat application. What can this do? This can do all these rich things like seat selection, and for airlines it can show you a product launch overview in an application here. These type of things. OpenAI took this idea and improved upon it quite a bit. They made it easier to use. They made some smart decisions around security and really improved the core idea to something that you can use in products. But we don't want to have this in an MCP. The idea is to write an MCP server once and use it everywhere. And what we don't want is a system that only works in ChatGPT and nowhere else. So we're working now together with the people at OpenAI. We work together with the people at MCP UI to make this an official extension to MCP so that more clients like Claude AI, VS Code, and others will support this in the future so that you can have these rich interfaces. Because I really believe that if you as a human interact with an agent or with like some form of data source, you not only want to always read text, you want to have things that are visual to you in certain scenarios, because we as humans, we fundamentally think very visual. And something like a product launch overview, I can instantly tell within 2 seconds, not even 2 seconds, 1 second of looking at it, I know where the problem is, here and here. But if I see this in text, in a chat application, I have no clue. I would need to read a lot, and it would be it would be way less nice for me to use. And similar, you might even have things like confirmation dialogues that you really, really care about. Other things that you can think about MCP UI enabling or MCP apps enabling is, for example, shopping. If you want to do shopping via an application like Claude AI, I use Claude AI all the time to give me ideas around which product between two products is better. But I also want to probably see it, and I probably want to even buy in the application. I don't want to go somewhere else. And so one of these things MCP apps will enable in the future is interfaces where I can then go and check out directly in one of these applications. And so that's, I think, one of the biggest things we will see next year is more and more of these applications that then will work across a wide variety of interfaces, ChatGPT, Claude AI, and others. The second part that I'm quite excited about in the future is that we're going to see better MCP clients. So I think this year was for most people around experimenting. What can you do with writing agents? What can you do with writing chat applications? What can you do with adding integrations? One thing people don't remember, an agent like Claude Code, agentic systems like Claude Code or Gemini CLI, they have been around for less than a year. So this field is rapidly evolving. And so we have just seen 11, 10 months of people experimenting with this. And now we're seeing a lot of the problems. And so in the MCP world, a lot of the problems come from MCPs lead to a lot of tools. So if you are in Claude AI and you enable 3 MCP servers, you will have so many tools that the tools itself will take up a vast majority of the context window. And that leads to you having less ability to use the context, but also everyone knows context windows degrade after the longer they become. And so this is what we call like context bloat, and that's a very big problem particularly for people that use MCP servers a lot. And so I'm very interested in seeing how we can do better. And I'm very excited that we just launched yesterday or on Monday 3 new tools from Claude AI, our developer platform, to help client builders do this. Now I do want to preface, this is proprietary APIs that exist only on Claude AI. They do not exist somewhere else, but the principles behind it, they can be applied everywhere. And the first thing is using tool search to write better MCP clients. So instead of loading all the tools directly and having 50 tools in the context window, instead you have one tool and that tool searches for tools. And when the tool is being called by the LLM, you go do the search, you return new tools, and then those tools are actually added to the context window. This is surprising that most people don't do this because it's basically just RAG, like retrieval augmented generation, applied to tools. And it's very obvious to me that that's what you should do, but people don't do it. The second part is a very interesting aspect that we talked recently a lot about, both around MCP, but also we have now an interface to this that is proprietary that you can use very easily. It's called programmatic tool calling. The idea being, if I want to, and I think I have an example here, if I want to, for example, read a GitHub issue and then get for every issue the GitHub, like more details, like about an author, for example. This is all pseudocode, it doesn't work, but anyway. An author, right, in traditional tool calling, I would have to do a tool call, then the LLM would take over, do another tool call, do another tool call, do another tool call, do another tool call. But if instead what I can do with programmatic stuff is have the model generate code for me that does all of this in one go, super efficient, because it does not need the result of GitHub issues. It only needs it temporarily. I don't need the result in my context. So instead, it generates this code, and then this code gets executed, and only the result gets into the context window. So we basically allow the model to combine the tools with program as a program in such a way how we would naturally do this as software engineers, and significantly reduce the amount of context being used and improve significantly the conciseness of the context window as a result. So this is what we call programmatic tool use. You can implement it yourself, but we give you in our Claude AI API an interesting way to just do that by yourself. You can just give it a bunch of tools, mark them as callable, and then it will just do all of it for you. And then lastly, in tool use, there's a small little problem in the that if you have certain parameters, it's not quite clear how you use them unless you put it into the tool description. So for example, there are things like date formats. It's not quite clear to the model what the specific format for a date is. So you can provide examples of how to use the tool. So those three things are things that I think you can do in every MCP client if you want to. But if these are proprietary features that exist in Cloud AI API that you can use to build better MCP clients using Cloud, of course. Okay. So what else is there? So we have now tasks, is the long-running stuff. We have our MCP apps. There's one more aspect that I want to talk about is the registry, because this goes into this problem of discoverability. And this is this problem that if I currently want to use the MCP server from Turkish Airlines, I need to go to find the URL, put it in, authenticate myself. And it's actually a workflow that is very much for developers and not for users. Users do not want to deal with custom manage my connectors interface. It's horrible. So what we want to build is a set of central registry for MCP servers. So this works as follows. We have a central public registry where everyone can submit their MCP server. Now that's a bad idea because nobody tells you what is a good server and what is a bad server. But it is very much a place where everybody can submit one. And that is very similar to NPM, packages, PyPy, these type of things. But then on top of that, what you can do, we're going to allow a set of sub-registries. So people can have their private registry where they curate what they want to show to their users and basically take this list and filter it and only provide those to users. And now what you have, you can give those to clients, and now those clients can do automatic discovery. Because what they can do, which one is the right slide? Is this the right slide? Roughly. What you then can do, you can write an agent that takes the question from the user, go to the registry and ask the registry, do you have an MCP server for this? Install the MCP server, and then go and ask the user to log in and continue the task from there. And that's really what we want to enable, which is this basically tool and server discovery. And if you have a central place to look at, you can do this. If you have a central trusted sub-registry that you can look at, it's even better. You probably do not want to automatically install servers from the public registry. You probably want some filtered registry that either you do yourself or something like Anthropic or OpenAI might provide to you. And so that's one of these aspects. And so then we have these automatic discovery mechanisms where the agent should automatically discover it. And we're getting closer to what matters to the user, because to the user only one thing matters: get my shit done. That's all the user cares. That's everything the user wants is start a task, finish the task. I don't care what happens. I don't want to hear about MCP as a user. The developer should know about MCP. The user should never see it, right? It should just work. And so this is the idea again here, agentic MCP discovery using the registry API. You can go to the API, ask for an MCP server, find the right server, install it, and then be done. And for that, we have the MCP registry. The official MCP registry is currently in like a preview state, but it will be stable very soon. And you can find this, I think, under registry.modelcontextprotocol.io, something like that. You will find it on the GitHub. But this exists already, and you can already submit servers today, and you can already build sub-registries with it. And then lastly, one thing I'm very, very excited about, and if you pay very careful attention, you will see where this goes. We will have something called web discovery. So at the moment, again, it is very difficult to find the right MCP servers. And what you will see is that browsers increasingly build AI into their browsers, be that Chrome, be it specialized browsers like the ChatGPT's or like OpenAI's Atlas browser, and other browsers increasingly have these basically AI-enabled browsers. But the interesting part there is, if I go to a website like Turkish Airlines, how do I know that they provide me like an MCP server? Well, the idea is we can tell you. we will build a standard that says, if you go to example.com, also check well-known MCP server.json. And if this file is there, then there will be an MCP server, and you will know everything about the MCP server. And now I can instantly have the AI application inside the browser use the MCP server. And you don't need to know as a user that there is an MCP server. All you did is you went to turkishairlines.com, and suddenly you can use the MCP server, right? That's where we want to be. This is something we are currently working on. This is a collaboration between me and OpenAI to put this into the specification for MCP. And in 6 months, hopefully, you will be able to use this. So while you're making photos, just note this is an idea that does not exist yet, but it's something we want to get to, right? So this is roughly where MCP is heading. Where I'm currently seeing is we have established a massive ecosystem. We have established the need for an open integration protocol like MCP. But what we are missing is widely used primitives for long-running tasks to enable richer agentic systems and agentic communication. We want to also enable richer interfaces for users so that we go away from pure text to something that humans really, really like to use on a day-to-day basis. And then lastly, we need to get into the business of making something like MCP, remove them for the users, make it purely for developers, and the users for the users it should just work. And then the users just want to put a task in and get a result out, and we want to do this via the registry and web discovery as part of solving this, as well as providing things like tool search and programmatic MCP. Use in order to enable much, much better MCP clients. And so what we hope for the next 6 months is that people just build these things better and that the product itself gets better. I think the protocol is nearly there. What needs to be done is a lot of product work. And for that, I think there's a lot of opportunity in the space to build products that are significantly better than what we see today. Cool. That's it.